So session you're in is future-proofing with DELMIA's factory automation tools. I know that I've had a couple people come and sit and realize they're in the wrong session. So if this isn't where you're wanting to be, you can go ahead and take off. But if not, I have something I think you'll enjoy. So how do you create an accurate and usable plant layout? And the keyword there being usable, because a lot of times we have plant layouts, but they're pictures, right? It's not modifiable. We can't do simulations with it. We can't really analyze anything. And DELMIA allows us to do a lot with it. And today what I'm going to show you is how you can actually use point cloud scan. So you bring in a scan of your facility and then also some manufacturing simulations. Starting to merge those two together, making them more dynamic, making them more alive, so they're not just static images of a place and time. So a quick agenda overview. I'll show you how to create a layout using point cloud, a very small data set based on a real use case, but we didn't had a customer data. They didn't want their data reused, but using some of the same theories. So we want to modify and verify that we have room on our shop floor in order to install a new cell. And then how do you modify a 3D work cell? So build it up in SolidWorks, but then what? At that point, it's just a picture of what you want to create. And then using that work cell to create a robot simulation. In this case, we'll be focusing just on arc welding with some external workpiece positioners and showing how you can then drop that into the point cloud, verify that everything fits, and be able to run it all together. A lot of times the limitation we come in with a lot of software is you have performance issues once you start getting over a certain size, right? It's hard to bring large amounts of data, visualize them, and use them without having that lag time. So first, we have this scenario. We want to find room on the shop floor in order to place machines. So we've determined that the pallet racking can move. It's not necessarily something that needs to be there. And then we want to see if we have space for those machines to put a cell next to it. So before I start, point clouds are great, but they're really big. And so the 3D Experience platform doesn't actually manage them in the cloud. What you have to do is you have to create a cache location for the platform to point to and reuse that data. I know in 2024 or 2025, they're adding that functionality, but it's not there yet. So you need to make sure you create a cache folder somewhere where everyone who needs to use it can use it, and give them access. So let's talk about the tree structure when you bring in a point cloud. I usually do a top-level point cloud bin, and kind of depends on how my departments are split up. If I have multiple cells that I want point cloud in, I might put one in each cell. And then a lot of times it's broken into little pieces. So when you bring the point clouds in, they're so big you chop them up to make them importable. And so each node corresponds to each of those smaller pieces of the point cloud. And then I always throw a roof node in there. So when I take that roof off, I can easily hide and show it based on what I want to see, where my simulation's at. It just makes it easier to get into it because otherwise it's a cloud of points and you have to navigate around that. And then I guess I forgot I had animations. And then you have a DELMIA resource. So in this case, we're showing a machine. Could be racking, storage. You could use robots, but typically you want those to be more dynamic. And under that, you would create your extractions to put your point clouds into. So keep your main area for kind of the outline of your building, and anything you want to convert into resources, your machines, your shelving, create your resource, and then put a product node under that resource. So that product node isn't necessarily required, but what it does is it makes that resource reusable. So if you need to type it as something else or import it into a more neutral format, that product node allows you to do so a little easier. All right, so what does an import look like? Well, it's a little different than you would normally import something into the 3D Experience platform. You actually have to be in the plant layout design tool, and you have to import it from the point cloud toolbar. I typically create my structure first. That just keeps me in line, otherwise I end up importing it to the wrong node several times. And you go select it using the import cloud command, make sure those parameters are set, and you click import. Typically this takes a couple minutes. I don't want to make anyone sit and wait through a presentation for that, but once it's in there, you can rotate it around and use it. Next step is to separate those resources out. So already did it with the roof, but now I want to separate some of those machines that I want to move around. And I'm going to use what's called the extract command, which allows you to draw a box around everything you want to separate out from your main point cloud. In this case, and usually when I separate out machines, I take the chip collectors, the workbenches with it, because you're not going to move a machine and not move the extra equipment. Also, it's less work. So I create that, and then I create a bookmark. So that way, if someone wants to go and find that work cell or that machine later on, all they have to do is drag and drop it into their own work cell. You still need to make sure they have access to that cache location that I talked about earlier. But it's there and it's usable now. And after I've separated everything, I'm going to modify my layout. So modifying, I'm going to delete that part of the point cloud. I'm getting rid of that palette shelving for sure. And so it can just go away. And then I want to reposition those machines. So typically when you're working with point cloud, it doesn't have a good reference frame. So you want to drag the triad onto the area you're trying to move and then move them. I guess here I'm doing it separately, or together you could do it separately, but it just gives you a better point. Otherwise that reference frame is floating in space. So you just drag it on, select both of them from the tree. Questions at this point? Is that clear to everyone? Okay. So next we'll start working on our 3D work cell. This is a robot welding cell with a workpiece positioner. And it's actually, I guess, 3 parts of that positioner. You have one that's rotating the different pieces around the robot at the bottom, and then each of the arms are going to rotate it up depending on what needs to be done. So start out, I'll redefine my resources. So usually when you bring in 3D, you're going to bring in a SolidWorks model or a step file, maybe something from another CAD system. So I'll redefine any resources that are there, my tooling. I'm going to just replace the robot models. So DELMIA has a robot library. I'm not going to worry about having to create the kinematics for those robots. Then I'll define my tooling, and that means different things for different tool pieces, and I'll mount it all together. So what are DELMIA resources? In SolidWorks, you have assemblies and you have parts, and you can have sub-assemblies, but really everything is one of those 2 definitions. Generalization, I'm not a SolidWorks person. But DELMIA has specialized resource types. And these specialized resource types are important because they allow you to activate and use certain behaviors. So in this work cell, we'll have a manufacturing cell, which will be our top level node. And we'll have our manufacturing product. So manufacturing products are just going to be the model of whatever you're making, assembling, manipulating. And it tells the software that that product is able to be modified without it being taking on permanent changes. So you can do the simulations without modifying the design parameters. Then we have a robot, which will be executing certain operations, and our tool equipment. Tool equipment can be vast. In this case, we have two. We have the workpiece positioner and we have the arc welder. So, start out by redefining our resources. This is done in the Robot Programming Essentials application in your, I call it the design space. So you have different tools depending on which space you're in the app. And I just use the generate a resource command. I do that for each of the resources except for the robot, defining them appropriately. Once you commit this command, you can't undo it. So once you've defined something as a tool, it's defined as a tool. I always save right before I do this because I've more than once clicked on the wrong thing and hit OK and not realized I did it, and you can't Control Z out of it. So I save, I do it, and then I save again, assuming I didn't mess up and have to close and reopen. Once I've defined everything, I'll replace the robots. And I mentioned that robot library. To get to it is a little, I guess, not super straightforward if you haven't seen it before. Before you launch your application from the web browser, you'll need to do a drop-down next to the Robot Programming Essentials app. And you'll want to select the Install Optional Content. You might be wondering why they don't just install that with the software. Well, if you start downloading it, it's something like 32 gigabytes worth of data. So you don't want to default install that unless you need to. And once you install it, it's located in the path shown below, typically somewhere aligned with your default installation path under Content tab. And it's broken down into two areas. You have your folders, which you can actually go into, and they can download individual robots. Any of the 3D XMLs on that top level, you'll have to import, or if you import those, you'll be importing the entire robot library of that type. So if you want all of the ABB robots that DELMIA has in its library, go ahead and import that one. If you just have a specific operation, go into one of those folders and find the robot that's appropriate. Questions on this? Okay. So replacing the robot. Typically when I'm doing this, I leave the design model alone until I've mounted my tools. So what I did, I imported it from the robot library, and then I just drop it into the work cell. Once you mount tools, everything moves, it shifts. You don't need to reposition it early. And I know sometimes that hurts the design guys' hearts because they want everything to be positioned where it needs to go. So I guess I'll back up one slide. Defining our tooling, I mentioned we have two. We have an arc welder and we have a workpiece positioner. So the arc welder, I just need to define some ports on. There's no kinematics with it. The workpiece positioner, I need to actually define those kinematics so that I can simulate how it moves. So ports define how devices interact with other devices. So robots, you have three basic types. Your TCP port will decide how you jog kinematic devices around. This is going to determine your control point of that robot or device. You also want to make sure you put it on any end-of-arm tooling so that when you mount it to the robot, it appears there. Then you have your base port, which defines where a child resource mounts to a parent resource. And then you have your mount port, which defines on the parent resource where those child resources will mount. So a robot will have all three of these because you need to sometimes mount it to things, sometimes mount things to it, and then also be able to jog it around. Quick table, my recommendations on which ports you create for which tooling. I've done a lot of these cells, and those are pretty accurate for what I've ran into. So you guys will get this slide in a couple weeks when they publish it. Feel free to reuse it as a resource. So defining the weld gun, I mentioned we need to define the ports. So I need a base port and a TCP port. So I've used the define ports command, and it has some tools that allow you to automatically locate a good location. So you don't have to create these access systems beforehand. However, if you're smart and want to create them in SOLIDWORKS first, it will make this job easier. But you can still use these tools to position it as you need. And then the TCP port, I'm going to select that surface of the tip and then actually select along the center line of the tip so that it points outwards, allowing me to be straight on. Otherwise, if you try to manually position that, you'll always end up at a little bit of an angle. Questions for that? I know these videos are fast, but otherwise you end up sitting and watching them for quite a while. So I mentioned you can create access systems in SOLIDWORKS. Typically, if you know what you're doing and you know the intention of your tooling and you're creating something in SOLIDWORKS and connecting it to DELMIA, I recommend that you create your access systems in SOLIDWORKS. And there's two things that you need to consider with that. One is going to be any of your port locations. So in this case, you can see mounted onto that pedestal in the middle, that's where we'll interface the robot. And why I say that is since SOLIDWORKS owns the CAD data, it owns the design data, you can't modify the design data in the 3D Experience platform if it is not the CAD owner. So what you would have to do is create more 3D shapes, and oftentimes not where you want them, and you're messing with your design data at that point, which isn't what you want to do in this application. So create your ports, and then if you have a kinematic device, create your access systems where things will interface. So in this case, you have this box, the black box, is going to rotate around the base of the robot. So I created two access systems actually, one under each product called base to one. And when you start creating your kinematics, if you name things appropriately, if they've been created appropriately, it will make your job a lot faster. So moving on to how to define that positioner. Well, I defined mount port for each of the toolings. Actually, let me go back. Mount port where the parts actually interface, and then this one was a little weird. It's something I raised to R&D, but I also created a base port where the robot's mounting. Usually that would be a mount port. And then I'm going to create the kinematics. So within the tool, they've, within the past couple of years, introduced the kinematics wizard, which is nice because when you start grouping joints together, you get a color code of what's happening. And if you look here, you can actually see that as it's defining those joints, it's asking me to select access systems from the dropdown. And so if I've had those labeled correctly, I know which access systems I need. And once I define everything, it allows me to, or I should check my kinematics. And I really, really strongly advise you to check your kinematics because I've definitely defined things and had things fly into space after I was done, especially with the old way of doing it. And then you mount your tooling. So quick command here. You can snap and then mount, which is a couple extra steps, but sometimes with your workpiece positioners or rails, you can move things around a little bit like this and it would snap to the wrong place because I want the frame to be the reference. And then you set the tool. So you select your child, you select your parent, and then you select which interface point that they're going from. And now you've built up your work cell, prepared to do the next steps. Questions? Yes.
How often what documents?
I think it's a yearly thing. Typically, they go through and just see if there's been any robots newly released, and then if there's not one in there, you can have it requested to be made. You can also always define it yourself. It's just a little bit of a tedious process. So. Okay. So next step would be to create my simulation, execute on a couple different things. So everything's mounted. Now I want to create my routines. And since I'd used this robot before, it did create an arc profile, which is a one-time setup thing. So it's not shown in this presentation, but it is just a small 30-second step. So first, you want to create your trajectory. And to do so, you would select on the line that it's going to, and then its support surfaces. Not necessarily required to select the support surfaces, but you'll get much better angles when you do so. And you can see and modify your tooling trajectory and make sure that it lines up with each of the tags. You have the reach and that view. You can also create a tool cloud, which automatically puts that tool at each of those points for visualization. Helps a lot of times if you're having issues and need to explain what's wrong. And then you create your arc operation, which will be automatically generated from your arc trajectory. So trajectory, operation, and then it generates your program. And you can click through it and see each of those steps. Small routines, I usually click through each step. Larger routines, I hit play and let it play. And then I have a nice workpiece positioner that allows me to update automatically. So I'm using the auxiliary axis programming, which is activated over there on the left. And I can set parameters based on how I want the robot to move. So generally, I like minimized motion. It keeps things from crashing. And I want to make sure that it starts with the workpiece up. By default, it put it downwards. So change those values, hit compute, and when I replay the subroutine, you can see that now the positioner is moving the workpiece so the robot doesn't have to work so hard. Really useful when you have arc trajectories because it makes it so that the robot's not trying to get in those nooks and crannies all by itself. Very similar routine can be used for rail equipment. So if you have a long rail, you can use the compute rail values and it'll say where your robot should be to execute each step of its routine. Questions? Yes?
When you're setting those trajectories, can you set it to say I want to do like a flat versus a vertical weld, or that, say in position?
I believe so. That's also something that you could define partly by the trajectory itself, each of those individual tags, making sure that it's oriented correctly for the angle of attack you want. All right, other questions? Cool. So after I validated, I want to insert it into my point cloud, right? I want to get that pretty simulation, which is why we're using the nice software. DELMIA doesn't measure point clouds very well. And if you look at how a point cloud is structured, that makes a lot of sense because it's a bunch of points in a cloud space and it's really hard to select on a very specific point. And so what I usually do if I'm doing work cells is I'll put any restrictions around them I need. So in this case, I need a 4-foot walk path. That's part of the parameters that have been defined. So I put that in usually in a very bright color so that I can easily identify it to make sure that it's not going to clash with any of my machines or other walkways. And then I can insert this into my layout. So typically, start from your bookmarks, drag and drop into your work cell. Makes it easy to find. You can always use the insert command. But now I'm able to drag that work cell over. It actually very conveniently fits about the width of where the machines were. And then you can play your simulation. I didn't show the full routine creation, but with each of your robot programs, you can actually add choreography so that when you're playing this, it zooms into the points that you want to highlight and zooms out at other points. So some people who are wanting to use this for marketing, that's a consideration to keep in mind. You don't have to always drag the screen around. All right. And that is what I've got for this. Questions? If you think of anything, if you need any additional resources, that's my email. Feel free to reach out. But thank you. Yes.
So it comes out as a problem. Does it take long to rebuild it?
What kind of problem are you anticipating?
Errors that come up, that pop up, I guess in the design, but as far as animating it,
So,
detection, as far as interference or
yeah, so you can turn on clash detection, which if any of the pieces bump into each other, you'll actually get everything lighting up bright blue as it goes through, which you see a lot with welding because you don't want to crash your tips, right? So, and then as far as modifying it, it depends on the extent that you're modifying it. So if they change out that tool tip, let's say you need a longer gun for some reason. If you you take the tool out, you remount the tool. In the program, you just need to change the point that it's referencing for those points. And you would highlight all of them, right click and say use this tool profile instead. And then everything else should stay there. So a little bit of a balance depending on what you're doing. Yes.
It might be out of topic, but we heard before noon that DELMIA can be a tool for having large production lines fitted together. We have one SolidWorks customer who struggles with visualizing the whole structure together. How flexible it is, how can it follow design changes? Would you recommend it for this kind of usage?
I think it's a much better tool than SolidWorks, for sure, because it's meant to handle those large data sets. As far as design changes, you need to make sure that you've set up your environment to actually have those design changes feed through. So they're using SolidWorks, you'd want to make sure they're either using 3D Experience SolidWorks or they just rebranded it, but the connector, right? So that when you make a design change, you would see that reflected in the cells. If you have that set up, anytime you make a change, you should see that change within the robot cell itself. Assuming you didn't duplicate data in the platform and use a duplicated, disconnected version of the tool.
Thank you.
Yes.
Is it a separate role that we can buy it, or we have to have DELMIA for through the automation?
So DELMIA is a large portfolio, and it's kind of the brand that encompasses all of the manufacturing tools. So for this, I showed two roles. If you want the point cloud, you need EFS, which is Factory Simulation Engineer. And then for the robot programming stuff, you would need RBS, which is Robot Programmer.
But the core DELMIA is not needed.
Nope. Yeah, those two roles, and then I think you need the access to the platform if you don't have it already.
which role would be used for this kind of visualization?
Which part of the visualization? Just the robot programming?
Fitting together a large
Oh.
production line.
What are they doing on the production line? Is it a bunch of conveyed systems, or I would use factory simulation engineer. If you want detailed kinematic movement, I would use robot programmer. So factory simulation engineer, you get the layout, and a flow simulation also handles the conveyors. And the robot programmer is made for, it says robot in it, but it's not just restricted to robots. If you have tooling or specialized like kinematic devices that aren't necessarily robotics, but you still want to be able to show that movement, you would need the robot programmer application.
And it can use the movements of SolidWorks. So
I would not create movements in SolidWorks and try to use them in DELMIA. I just wouldn't even create them in SolidWorks, if I'm being honest. I would create them in here, and then it's really quick, and you don't have to worry about mate connections. Dawn has more SolidWorks experience than I do, but
Just try to set up limit mates and it's so much faster. Sure.
yes.
Small question. Do other companies have data sets that it's covered in that already? Or is that something?
Yeah, so basically if you're wanting to pull something in from, say, Shunk for tooling, right? You want to be able to do that. You can import step files, is usually what I use if I'm pulling it down from a company's website. I've also used, I can't remember what they're called. But it's a company who builds like little small automated work cells. So if I'm building a demo that I want to look more realistic, I just build that up and then download a file, all step files. You can import just about anything. So you have Step, Creo, your SolidWorks, your CATIA data.
As far as like specifics, let's say a specific arm has ability to move and axes, and you got that ability to add that to.
So,
Buy like a Motorola arm, for instance, and it comes with a data file of everything that it can do.
right. Yeah, so two options. There's the robot library, which DS R&D goes through every once in a while and refreshes. And I think I've seen Motorola in there. If it's not in there, what you would have to do is you'd have to import the solid model and then define all of those joints and the limits associated with it, both motion and speed and acceleration. So you can pull anything in, it's just not going to automatically generate it based on its data sheet. Other questions?
Does it support the arm that is moving on rail?
Mm-hmm. Yeah. I've done a lot of that. So, typically what you would want to do is make sure that it aligns to how the real world robot's working. So if the arm and rail are associated on the same controller, you'd want to make sure when you mount it that they're using the same control device. That way when you export the program, that rail value comes across. Otherwise, if it's on a different controller, you have to go and make sure those values get onto the rail as it's moving, usually in the form of signals.
When we define the path, for example, let's say that it is an omega shape, sheet metal part with to a structure, and there is a pattern that path. Can we do the pattern or the mirror for the path? I saw it in other software, so is it possible, or do I have to recreate it for each separate part?
The pattern, what kind of operation are you doing with it? Is it a weld or a weld? If you want to simulate it, you have to recreate it for each. That's something I brought up with R&D a couple times. So, but if you want to put it in a program, you can add the logic to iterate the pattern every so often. Other questions?
Can you repeat the name of the two roles, DELMIA Factory Simulation Engineer and the other one?
Robot programmer?
Robot.
Yeah. Okay. Other questions? All right. Well, thank you guys.